Hi! It's been half a year since I made a video about building DIY NAS. Since then, it has been running smoothly, and I have no complaints. But I still had to keep a backup of my photos in the cloud, and even though editing videos directly from the NAS was incredibly convenient, I couldn't shake the feeling that I was keeping all my eggs in one basket. Having RAID gave me some peace of mind, but RAID is not a backup. It won't protect my NAS from the power surge, theft, or whatever can happen to it. Until I have an offsite copy, my data isn't truly safe. And to get the true cloud level protection for my data, I've made a few upgrades to my NAS, and the main one, setting up a synchronized Backup NAS. There are a ton of interesting nuances here, and I'll share my journey with all the details in a simple words. The most ironic part of this whole story is that while making this video, I lost about 65 GB of footage and screencasts. This video was almost completely edited, and now I'm editing it for the second time from scratch. Even though original footage is gone, I will re-record the screencast, tell you what happened, and explain exactly how you can avoid my mistake. And one of the main things that can help me to recover from such a moral trauma is your likes. Thank you. So, what's my perfect backup NAS? The biggest factor for me was location. This thing is going to live at a friend's apartment. And he doesn't exactly have a dedicated server room. That means that it has to be compact, practically silent so it doesn't bother anyone, and power efficient so it doesn't spike his electricity bill. Raw performance isn't a huge deal here. Its only job is to sync data once a day or however I'll set it up. For a backup NAS, doing a custom DIY build feels like overkill. I'd honestly rather just buy an off-the-shelf solution. I could go for one of the cheapest pre-built NAS, but those are usually single bay, and I wanted an option to expand later, which means I need to look at 2-bay models. But the moment I do that, I'm suddenly in 200 to 400 euro range. And the hardware specs? And they run their own pre-installed operating systems, and there is no guarantee that synchronization will work the way I've planned. So the ability to reinstall the OS on TrueNAS is also important to me. There are other options that you won't find on the shelves of your local tech store. My last NAS video got a really warm reception, and ZimaSpace offered to send me the ZimaBoard 2 for review. When I saw this tiny NAS that literally fits in the palm of the hand, I told them right away that I see this as a perfect offsite backup. But I'm not ready to buy the hard drives for now, so maybe we can do it later. Their response? We love the idea and we want to support your project with absolutely no strings attached. So, this video is happening only thanks to them, and I still have 100% creative freedom to say whatever I want. And I'd like to personally thank them for being so understanding in this whole data loss situation. No one rushed me to release the video, and they gave me as much time as I needed. And trust me, I needed a break. So, Guide from the ZimaSpace was kind enough to help me with my backup project. And this thing is gonna cover it all. We have a ZimaBoard in this box and some accessories up here. They also sent me 2 hard drives, 6 TB each. And I'd like to see the board itself first. We got some welcome letter and the board itself. It's so tiny. Can you imagine? This thing has the same CPU as my NAS. That's crazy. I have no clue how much RAM does it have yet. And what I saw from the images, this can be used as a case. I like the packaging. It's simple and can be used. So I need kind of like this. And I have space for 2 SSDs. I think for most people it might be enough, and you have complete silent solution for your backup data. Let's see what we have from the port side. We got 2 ports for SATA,
This one I don't know yet. This is PCI slot, which can be used for GPU, for extension, for 10 gigabit connection, for example. Mini display port, 2 USB, 2 by 2.5 gigabit network. Let's see what we have here in the accessories. There's a lot of things. I didn't expect it. So obviously we have a power adapter. Up. I have no clue where this fan goes yet. Aha, now it makes sense. I need tiny fingers to make it work. So now 2 hard drives can be connected here. 2 tiny screwdrivers. And that's it. These adapters come separately. And here we have HDD rack. As always, I didn't watch any videos, any instructions. I like to figure out everything myself. So maybe I will be slow at some places, but we'll make it work eventually. There is a rubber surface here, so I guess I should just put it here later, just like this. I'm gonna need to read the instructions for this. And the fan, interesting, so tiny. So as for the hard drives, I was able to choose it myself. This time I decided to get Iron Wolf. They should be a bit quieter than my previous hard drives. Eventually it will be something like this. Boom, boom, boom.
For now, I don't need the whole setup, since I just want to test the capabilities of the built-in OS. So I connected it only with one drive. As I expected, it turns on automatically when powered on, and here's the power indicator. After booting up, the screen will display the IP address that can be used to access the web UI. But within a minute, it became clear that I didn't need the monitor. I could just download the Zima client and it would detect our NAS automatically. It also helped me with the initial setup and added the built-in storage as one of the drives to my computer. The main user interface will be in the browser. The very first thing I did was to update the OS to the latest version and format the hard drive. There, I was greeted by a friendly user interface that clearly explains and demonstrates the options for a single drive, a RAID array, the difference between them, and so on. And that's something I needed when I was setting up my first NAS. I chose a single drive and started looking for backup options. Before we move on, I want to share a list of requirements for a perfect backup NAS. It has to be offsite, far away from my house for obvious reasons. 24/7 availability. I want instant access to my files if my main NAS goes down. Fully automated synchronization, set it and forget it. And full disk encryption, because I'm putting this NAS in my friend's apartment, and I absolutely refuse to make my data security his problem. It's just about peace of mind. If someone somehow steals the physical drive, they got absolutely nothing. Modern encryption barely impacts read and write speeds, but to access the data, you need the password. To make this work seamlessly, the operating system needs to support drive encryption. Unfortunately, I couldn't find this feature in ZimaOS out of the box. Yes, it has a backup tool, and I could technically just store pre-encrypted files on it, but that workflow is just too clunky for what I want. And finally, I want this little NAS to be actually useful for my friend who is hosting it. The ZimaBoard 2 comes with either 8 or 16 gigs of RAM. I got the 16 gigs version, and honestly, letting that much memory sit idle on a simple backup task is practically a crime these days. It needs to do more. So I thought, why not run TrueNAS as a virtual machine inside ZimaOS? It supports VMs, so I downloaded the TrueNAS ISO and set it up. Since this is a VM, it doesn't have access to the hardware. After tweaking the LAN bridge settings, I got it appeared on the local network. However, there was no such options for the hard drive. So I scrapped that idea. For my specific backup requirements, the ZimaOS just wouldn't fit. Here's the new plan. I'm ordering a PCIe to M.2 adapter for the ZimaBoard. I'll install an M.2 SSD and set it as a boot drive, and install TrueNAS directly on it. Why not install it on the 64GB of built-in storage? Because it's eMMC, and I've heard that TrueNAS performs a lot of read-write operations, and it can wear out the storage quickly. Also, I'll still have ZimaOS, and at any moment I can switch to it if I want to. The upside of this whole setup is huge. Since I run it on my main NAS, I can set up a native replication task to ZimaBoard. Security is also much better managed, since I can use ZFS-encryption, and if someone unplugs the drives or steals the ZimaBoard, the data remains locked. But for me, I just log in into the UI, click unlock icon, enter my passphrase, and the drives mount instantly. No third-party decryption tools needed. It's secure, the sync is seamless, and it just sounds like a perfect solution. The only downside here is that my friend loses the user-friendly ZimaOS interface, and I had already mentioned to him that he could run VMs on it, which he was actually quite looking forward to using. So it was time to finally look into Proxmox. Some of you guys mentioned in the comments of my DIY NAS video, calling it, let's say, the next step of evolution. And it makes sense. It's a hypervisor that allows me to turn this tiny board into a proper home server, where TrueNAS is just one of the virtual machines. This way, we both get exactly what we need. I've seen videos about Proxmox before, and I always viewed it as something overly complex, something that I honestly didn't want to mess with. That is why I installed TrueNAS bare metal on my own build. But to my surprise, the Proxmox installation was actually very straightforward. Once it's done, you get an IP address to the web interface, and out of all the menus and features there, I only needed one to get started. Upload ISO image. I uploaded the TrueNAS installer, allocated just 2 CPU cores and 6 GB of RAM, which should be plenty for a backup server. Anyway, I can always adjust it later if needed. And just like that, we have our first VM running the familiar TrueNAS setup. After the installation, as expected, TrueNAS couldn't see the physical hard drive inside of the virtual environment. But Proxmox has a feature that allows you to pass the drives directly through the VM. Once I configured that, the drives appeared right inside TrueNAS. I immediately set up my storage pool, giving me 12 TB of usable space, and at this point, my offsite backup NAS was completely ready for the initial sync over the local network. Let's get back to the main NAS. Since I wanted everything encrypted, the best approach was to create an encrypted dataset inside my existing pool. For decryption, TrueNAS gives you the option to use a file or a passphrase. I went with the passphrase option and immediately saved it to my password manager. Because, let's be real, if I lose that passphrase, I can say goodbye to all my data I'm trying to protect. Once that was set up, I moved my data into this new dataset. The goal here is to keep all my data encrypted on my main NAS from this point forward, and to use a replication task to mirror this dataset directly to the backup NAS in its fully encrypted state. That way, if I ever need it, I can simply unlock it once and access the files at any time. To set up synchronization, we head over to Replication Tasks and create a new one. First, it asked for a new SSH connection, where we enter the IP address of the backup NAS. I'm just using the local IP for this initial sync, and the admin credentials. Back to the replication menu, we select that new SSH connection, and the storage pool from the backup NAS should show up. We tell it what to copy, where it should go, set a schedule, and start the process. Once the copy process finally started, it was a great feeling seeing it work exactly as I planned. The pool appeared on the backup NAS, I could unlock it using the exact same passphrase, and by enabling the SMP service, it immediately showed up as a network drive in Windows. And if I lock the dataset in TrueNAS, it instantly disappears from the network. Perfect! By the next day, the initial sync was complete. But remember, this was all done over my local network, and this NAS is moving to my friend's place soon. So it was time to set up a VPN. I installed and configured Tailscale and grabbed its assigned IP address from the admin panel. Since Tailscale was already running on my main NAS, all I had to do was to swap out the local IP for the Tailscale IP in the SSH connection settings. I tested the connection and it worked flawlessly. But to test it in practice, I added a new file to my main NAS and manually ran the replication task. It immediately returned a success status, but the file didn't copy. This is where I really learned how ZFS replication works. It doesn't monitor your files in real time. It relies on snapshots. When I created the replication task, it automatically created a periodic snapshot task. These snapshots essentially take a picture of the dataset at a specific time. So the replication task showed a success because the snapshot version on both servers were already identical. It didn't know there was a new file, so keep that in mind. With everything finally configured and ready to go, I stumbled across a comment on my NAS video. Just an innocent question about average lifespan of hard drives. But it made me rethink my entire setup. The reality is, depending on operating conditions, a typical hard drive has a lifespan of about 5 to 7 years. Over the last 3 years, I've accumulated over 3 terabytes of data, and I have 24 terabytes NAS. This tells me two things. First, I'm making my videos way too slowly. Second, at this pace, the drives will die of an old age way before I ever fill them up. So I started thinking, right now I have 2 6 terabyte drives and 3 12 terabyte drives. What if I buy just one more 6 terabyte drive, combine it with other 2 and put those 3 in my main NAS? I take just one of the 12 terabyte drives and put it into the backup NAS. With this setup, I will have matching storage capacities across both servers, which is more than enough space for the next 5 years. The 3 6 terabyte drives will theoretically be quieter since they spin slower than my 12 terabyte models. The performance might be slightly lower, but with my SSD cache drive setup, I don't think it will be noticeable. Migrating the data wasn't an easy task. Since my main NAS is configured in RAID Z1, which is similar to RAID 5, I pulled one of the drives without interrupting the system and connected to the ZimaBoard. Using a replication task, I transferred the data to the 12 terabyte drive, then replaced the remaining 2 drives with 3 6 terabyte ones. I set up another replication task, but this time going from the ZimaBoard back to the main NAS. After the data was moved, I immediately disabled that task. But because of this, the main NAS thought it was a backup, so I had to manually turn off the read-only mode in the dataset settings. At that point, the data migration seems like a complete success, but this would lead to some terrible consequences later on. On the backup NAS, having one drive instead of 2 means less noise and lower power consumption. And the best part? I'm left with 2 12 terabyte drives that I can simply sell. If I ever need more storage in the future, I can upgrade when higher capacities will inevitably be cheaper. It just feels like a win-win situation all around. This part of the script was written a long time ago and has aged well. I don't even want to change it, and I hope that in a few years I'll turn out to be right after all. After swapping up the hard drives, the system's overall power consumption dropped from around 50 watts to an average of 35 watts. But the most importantly, my main NAS is now way quieter. In fact, it's so quiet that I don't even need to spin down the drives anymore like I used to. And that's a good thing, because as many of you correctly pointed out in the comments, constantly spinning drives up and down can actually reduce their overall lifespan. Also, just as I expected, I haven't noticed any drop in read speeds while editing videos, despite moving to the drives with slightly lower hardware specs. On top of that, Since there is still plenty of free space on the Backup NAS, my friend can easily create his own encrypted dataset in TrueNAS to store whatever personal files he wants. He can take advantage of a local media server like Plex or Jellyfin, and if he ever wants to experiment, he can spin up his own virtual machines right there in Proxmox. The only thing left was to drop it off at his apartment, but since the ZimaBoard was unplugged for over a month, I decided to do one last local sync and record a screencast of it. And that's where I made my fatal mistake. You see, I opened the wrong TrueNAS tab in my browser and triggered the replication task, completely forgetting that I created a reverse task on the ZimaBoard earlier just to migrate the data. Unsuspecting, I went back to editing my video and literally watched my files vanish right in front of my eyes. Under the hood, the system was doing exactly what it was told, taking a 5-week-old snapshot and overwriting my main NAS with it. It just took my brain a minute to process the disaster. Now, how could I have saved myself? Well, previously I had automated snapshots running daily, weekly and monthly. These are the exact same snapshots used for replication. And the beauty of them is that you can instantly roll back your entire drive to the exact same moment the snapshot was taken. But here's the kicker. Because I had swapped my hard drives earlier, my automated snapshots broke. And I never reconfigured them. So for me, those files are permanently gone, along with 5 weeks of work on this and other video. To make sure history doesn't repeat itself, I am now using every data protection method available. And I strongly suggest you to do the same. Anyway, after that nightmare, I finally took the ZimaBoard over to my friend's place, plugged it in, and it immediately showed up on my network through the VPN. After that, I checked the status of replication task for several days and didn't encounter any further issues. The backup task can be considered complete. There is one more layer of protection, not just for your data, but for the physical NAS itself, a UPS. For those who don't know, it acts like a giant power bank that keeps your NAS alive during a blackout, while simultaneously shielding it from dangerous power surges. And setting this up has some really interesting nuances. In my first DIY NAS video, I mentioned that a power surge can travel through an Ethernet cable, and modern UPS units have ports to safely pass this cable through. But there are a couple of nuances. First, passing your network through UPS will likely cap your speed at 100 megabits per second. Second, I use a fiber optic connection, which is mostly made of glass and plastic, so it doesn't conduct electricity anyway. In my case, surge protecting the network cable is pointless. But here's the cool part. From what I understand, because it's fiber, if the power goes out while my router is connected to the UPS, I will likely still have internet access. And even if I don't, I will still have access to my local network and apps like Jellyfin. So I plug the router to the UPS as well. Another crucial feature is USB connection, which allows you to plug the UPS directly into the NAS. This way, the NAS know exactly what the battery percentage is and follows specific protocol to shut down safely. I set mine to automatically shut down itself and the UPS when the power gets critically low. There are other technical nuances to look for, like pure sine wave and line interactive topologies. I'll be honest, I consulted AI when choosing a UPS. I ended up getting this Cyber Power model. It is line interactive, and while it doesn't have a pure sine wave, my NAS consumes so little power that it doesn't even matter. It successfully passed the pull the plug test and is capable of keeping my NAS with router running for about an hour. So, with all these upgrades in place, I can finally say with confidence that my data is truly secure. And I'm completely free from paying for cloud storage subscriptions. A huge thanks to ZimaSpace for helping make this project a reality. I'll leave a link to ZimaBoard too in the description below. And if you enjoyed this video, I'd really appreciate if you leave a like and share your thoughts on my journey. And if you haven't seen my first video on building DIY NAS, why not check it out? It's full of useful information. Bye!